Welcome to The Explainer. So, we've all seen AI get incredibly good with words, right? But what comes next? Well, today we're going to look at something way bigger. Teaching AI not just to talk about our world, but to actually understand it, to get a sense of physical reality. All right, so here's our game plan. First, we're going to talk about an amazing superpower that you use every single day. Then we'll see why today's AI has this huge blind spot and how a totally new approach is trying to fix it. We'll get into the nitty-gritty of how this new tech works, check out its impact in the real world, and then wrap up by looking at what this all means for the future of intelligence itself. Let's get into it. So before we even touch on machines, let's talk about us. Let's talk about a superpower we all have, something evolution has been fine-tuning for, just about 500 million years. Imagine this. You see a glass teetering on the edge of a table. What happens? You lunge for it, right? You don't stop to think. That instant, almost primal reaction to predict its path and catch it, that is your spatial intelligence. It's this incredible, lightning-fast connection between seeing something and doing something about it. And this instinct is running 24/7. It's how we weave through a crowded street, how we manage to assemble that piece of furniture without looking at the instructions. And it's even how scientists were first able to visualize the double helix of DNA. It's a skill that's so much more fundamental, so much more ancient than language. But here's where it gets really interesting. For all the mind-blowing things they can do, the large language models we use every day, they've been completely missing this crucial ingredient. I mean, we've all seen it. AI can whip up poetry, it can write flawless code, it can even debate philosophy or create these breathtaking images from just a few words. They've absolutely mastered language. But there's a massive gap between understanding a one-dimensional string of words and understanding our four-dimensional reality. See, language is sequential. It's one word after another. But the real world is spatial, and that's a whole different ballgame. So without this spatial intelligence, an LLM is kind of like a brilliant mind stuck in a dark room. It can write you a perfect encyclopedia entry on gravity, but it has zero intuitive grasp of the idea that if you let go of a ball, it's gonna fall. It's totally disconnected from the physical rules we just know in our bones. And this is the perfect example of the problem. An LLM could talk chess strategy like a grandmaster, but then in an actual game, it might try to move a pawn sideways. Why? Because it doesn't have a persistent internal model of the world. It doesn't truly understand the board. So, how do we fix this? Well, a new generation of AI pioneers is jumping on this problem with a totally new philosophy. Don't just string together words, build entire worlds. And right at the front of this charge is a company called World Labs, co-founded by Fei-Fei Li, who many call the godmother of AI. I mean, her earlier work on the ImageNet dataset is basically what kicked off the whole modern AI revolution. And now, she's looking to start the next one. Dr. Li actually calls this moment a digital Cambrian explosion. And that's a fantastic analogy. She's comparing it to that moment 540 million years ago when the evolution of eyesight transformed life on Earth. Suddenly, creatures went from just passively floating around to being active agents that could hunt, hide, and truly navigate their environment. Okay, so this all sounds great, but how do you actually teach a machine to get 3D space? Well, the secret sauce is a total shift in how these AI models are built, moving way beyond flat pixels. So instead of just looking at a video and trying to predict the next frame, these new models do something called lifting. They take that 2D information, a picture or a video clip, and they reconstruct the actual 3D reality behind it. They're not just painting a picture, they're building the scene. And this is the really critical idea to grasp. The AI isn't just making another flat video. No way. It's building a real, stateful 3D environment. It's an actual digital space, and it's made up of millions and millions of tiny, intelligent particles. These particles are called Gaussian splats. You can think of them as super smart 3D pixels. So you know how old 3D models were made of those clunky-looking polygons? Well, these splats are way more advanced and efficient. And because of that, they can create these incredibly photorealistic and persistent worlds that you can literally fly through and explore from any angle, not just the one view a video gives you. And listen, this isn't some far-off sci-fi concept. This tech is here and it is making huge waves in the real world, like right now.
Take robotics. There's always been this big problem called the sim-to-real gap. But now, instead of taking weeks to build just one simulation, robots can train in millions of unique, realistic AI-generated worlds. They're learning how to handle our messy, physical worlds safely and efficiently.
Or what about for filmmakers? This is a total game changer. It's democratizing virtual production. Something that used to require a Hollywood studio budget and giant LED stages can now be done by an indie creator who can generate these dynamic, explorable 3D sets from just a text prompt.
And it's coming for us, the consumers, too. Apps are popping up where you can just take a photo of your living room, type "make it mid-century modern," and then instantly walk through that redesigned space in 3D on your phone. It's incredible. Unsurprisingly, the market is paying very close attention. World Labs just raised over $1 billion. That's a huge signal that we're seeing a massive strategic pivot in the tech world, away from just language and towards this embodied spatial AI. And that brings us to the big picture. This is now a global race to build these world models, and it really makes you think about what the future of intelligence itself is going to look like.
World Labs is definitely not alone here. You've got major labs all over the world attacking this problem from different angles. Some are focused on creating these persistent worlds for filmmaking, others are building interactive gaming environments, and some are even trying to teach AI to reason about abstract physics. The race is on.
But the ultimate vision here, at least as its creators see it, isn't to replace us. The goal is to supercharge human creativity. It's about creating AI that can act as a true partner, helping us design, build, and explore our physical world in ways we're only just starting to dream up.
So that's the big question we're left with, isn't it? AI mastered language, and it completely reshaped our digital information world. Now that it's starting to truly understand space and physics, how is it going to reshape our physical world?